Hi everybody, this is Josiah. Today I'm going to talk about another LeetCode question, which is called maximum subarray. This question is given really high rating on LeetCode platform. So I believe I might attempt to make a tutorial about this problem before, but I think this is typically a good question, so I will go over this again. The question goes like this: given an integer array nums, find a contiguous subarray containing at least one number, which is the largest sum, and return its sum. So what does it mean? If your array like this, so this question doesn't restrict a negative number to appear in an array. So there might be some negative numbers right there. All right, I just placed random numbers into this integer array. Okay, now you're going to find a contiguous array. I want to emphasize the concept of contiguous array. It's something seen very commonly in operating system class. So contiguous means there is nothing to cut the array into half. For example, I want a subarray like this. Okay, so this is called a contiguous subarray. However, the array consists of -1 while skip 2 and continue from -1 to 9. This is not considered the subarray, contiguous subarray. All right. That means this subarray is selected from this entire big array, and each element has its neighbors on both sides. All right, you cannot skip any element to compose a new subarray. All right, I'm not sure if I explained this clear enough, but the graph is worth 1,000 words. Now, what do you think? Because there are some occurrences of negative numbers or negative integers in an array. In your first thoughts, you might want to, if you see -1 as first number, you want to skip it, right? You intuitively want to skip the first number and start with the second number, because if you include -1 into your equation or into your subarray, then it will only do harm. You will only decrement your entire array by 1. So you don't want to pick -1 as the beginning integer of the subarray. So if you have a 2 in the beginning, you have -1 next 2. What do you think? You're going to include the -1 or not? No, so here you have several options because you cannot foresee what the next element is. So if you, for example, if you include -1, so within this subarray, so for this subarray consisting of 2 elements, right, including the -1 will hurt your result, right? It will decrement your final result sum. This total sum is equal to 1. However, if you include you're not able to add 3 into your contiguous subarray, right? If you skip -1, when you include 3 into your subarray, it actually will help you to boost your total sum to 4, and so on and so on. Then for example, if I take -1 and 2 out of the equation, take -1 out of the equation, start from 3, will this definitely help you? Actually, no, because it's just the other way around, right? If you eliminate the -1 out of your subarray, then you're not able to add 2, which is positive number greater than absolute value of -1. So it hurts your total sum, but is set as a bridge, right, between 2 and 3, and so on, so forth. That's an interesting question, right? But how do we, because we got a bunch of random number in this integer, we cannot manually pick those numbers to decide. So we have set out the rule. So that's why we need several local variable to keep track of the current maximum and the current maximum and the numbers that we're pointing at right now. So let's set up something called current number, and you can use, call this array nums, so you can use the index I. All right, we just need to iterate through this array only once, which has a big O n running time. So you have a current sum. You have a current sum. I'll explain the meaning of current sum later. You have a max sum. Okay. So this is the first one, easy to understand, right? It's just let me control this. It serves as iterator going from the beginning to the end. Right. So -1. So in our first iteration, the number at the index of I is equal to -1. Is -1. So what our current sum is? So our current sum will be equal to -1 as well. So actually the current sum, let me write out the formula, equal to the max between the number and the current sum plus number I. So what does it mean? So in this case, current sum will be initialized to -1, compare current sum plus -1. So that means on top here, let me use the eraser. We can either initialize current sum to 0, or to cut it short, we might want I to be initialized as 1, index 1. We can start on the second number and initialize our current sum to be the first integer in this array. So I in this case will be equal to 2. All right, let's rewrite it. Then we compare -1. Okay, compare -1 with -1 plus 2. What do you think? Of course, we choose second one, right? The positive number is always greater than the negative number. Then now current sum will be updated to, let's show the stack, 1. What about max sum? We'll compare the current max sum. Current max sum will also be initialized to the first number. All right, max sum. Then we compare the current sum with the max sum. All right, the current sum equal to 1. Then we update the value of max sum. Let's switch the color to 1. Oh, in the next iteration, all right, let's see the next iteration. We have the number at the index of I equal to -1. Okay. Oh, sorry, I made a mistake. So here, this is equal to 2. Let's rewind it back. All right, I'll cut it this. I'll run back. And 2 plus -1 equal to 1. So compare 2 with 1, then the current sum will be 2. The max sum will be updated to 2. Sorry, made a mistake. And in next iteration, we have -1. Okay, so that become the interesting part, and then we just briefly went through. This one need with -1, and 2 plus -1, again, will be less than 2. Will be less than, sorry, it will be greater than -1, right? Now the number is -1. So, okay, we might consider keeping this. So you might be worried about, what about the 2? Right, now we update the current sum to be 1. We lose the track of 2. Actually, you don't, right? Because the max sum 2 we have seen so far is being stored in the max sum variable. That's why we need the actual variable to store this information, right? As long as we have a positive number stored in the current sum so far, we can just keep doing. We can just keep updating this value. We see 3 right now. It's like a big treasure, right? Because we still have a positive current sum so far. If we add a positive current sum with any positive number, we can get a greater positive number. Then we can compare the positive number we get with the max sum we have seen so far. See which one is greater, right? If it's greater than the current max sum, then we update the max sum. If it is not, we just keep adding up new number like 4 into our current sum. All right, let's see how it goes. So now we have 1, and then we have 3 plus 3 plus 1. Compare with 3 plus 1, and this one is greater. So we update the current sum value to 4. Compare 4 with 2. Right, both are equal to 4 right now. Then we add new number, 4. 4 plus 4. We got 8. All right, just keep doing this, and we add a 9. We add 2. Right, all these are positive numbers, so they don't get any negative impacts on the total sum. So 11 plus 8. I just skip a couple steps. We got 19. Right, now we're facing a negative number, -3. So -3 compared to -3 plus 19. All right, 16 is a positive number, so reserve that. Now we got a positive number again. That's why we keep -3, right? We don't know what will be happening in next. Will be the next number, so we just keep. All right. As long as the current sum is still greater than 0, that's possible that we can build a subarray greater than, how to explain that? As long as our current sum is greater than 0, we want to keep it for later use, because after adding up some negative number, there might be some positive number, right, tailing after the negative number, so we don't know. So as long as the current sum is positive, we keep it, right? Okay, now we got this 4. Next, four plus this is greater than 4. And yeah, because the current sum is positive, so that's why a positive plus 4 is greater than 4. So keep going. Now we have 5. All right, then that's our final result. Though the entire subarray will expand from beginning to the end. Right, this contiguous array. Only the first element is out of the equation. Right, let's see the Java implementation.